Hello everyone. Today is the day 3 of 75 hard research challenge, and I'm going to give a brief introduction of what I studied on the day 2, which was yesterday. So I studied something called LLM evaluation, where we evaluate how good the output of a large language model is. Okay, so there are multiple ways to do it. For example, there are mechanical like human level ways. There are automatic evaluation methods also. So for example, there is a chatbot arena, which is a website where a user is asked to put in a prompt, and against that prompt, two of the randomly selected models are asked to generate the response. Then the humans are asked to rate these two responses, which one is better and which one is not, and eventually they will create a ranking out of this. So problem with this is that first, humans are very subjective, but overall if you average it over a n number of humans, so you are supposed to get a very good score. But there is an underlying problem that if you upload a new model today, that it is going to take considerable amount of time before it collects some votes and ranking system, right? And in general, it is not applicable to various tasks. For example, you will need domain experts to evaluate some a chatbot or a model that produces information about, let's say, medical or technical or mathematical things, right? And plus it is not scalable. What if tomorrow humans or users stop using this particular arena, right? So that essentially leads us to automatic evaluation, which is, for example, the most basic form could be in the form of perplexity, which is essentially capturing, given a sentence, how good your model is in predicting the correct sentence that was supposed to predict. So mathematically, it implies that it is a exponential of negative log likelihood of generating a sentence. So it essentially means that it is negative exponential of uh, pro- product of I is equal to 1 to n, and 1 by n probability of w I given w less than I, right? So this is the perplexity, but the problem with perplexity is that it is not a very good measure because it is solely based on what is the reference text, and it is probably not a good idea to judge a model on for creativity on this, right? Then we studied that what is a machine translation task, and how do we evaluate on a machine translation task the performance of a large language model, right? So for example, we can ask humans to tell what is the adequacy and fluency of a particular generated text or a particularly generated translation. So adequacy means that is the translation conveying the meaning in the original language that was provided in the original language, right? And fluency means how good the model is in terms of the flow of the sentences or the structure of the sentences, and whether it is grammatically correct or syntactically correct, etc., etc. Again, the problem with this human evaluation is that it is expensive, subjective, and we have to give very specific guidelines to humans to judge a particular generation and not, right? As we will see in the later part of the this as like lecture also. Okay, so we move to the automatic evaluation, and there are multiple ways to automatically evaluate, which has been used from the past 20 to 25 years. They are known as precision, recall, and F measure. So precision essentially means that how much correct match you have with the correct output that you were supposed to generate. For example, if you have like a reference which you are supposed to generate and the output of the model that you have generated, then we essentially check what is the correct match, word to word match, divided by output length, right? So it solely focuses on what is the precision of your output. That essentially means how much fraction of the output matches with the reference. On the contrary, recall means that what is the intersection of these two. That means what is the match, a number of matches divided by the reference length. That means the original length of the sentence that it was supposed to like produce. And people have developed measures on top of it that use both of them. For example, F measure is a very popular measure where they simply multiply precision and recall and then divide it by the average of precision and recall. Now the problem with these is that this is a word level matching. That means that there is no syntactic meaning because semantic meaning that is getting checked. For example, if there is a sentence, this is a boy, and your model outputs boy is a this, then the precision as well as the recall will be very high. But that is not a good like for example a translation or right kind of this is not the type of output you would want, right? And this is essentially captured in the second point here, that it is a bag of words model. That means the order is ignored, right? And to get a high recall, what you have to do is just your model should, if the model outputs the whole of the vocabulary, right, V, then the recall will be very high, because there will be 100% match in the generated sentences and the reference, because the reference is anyway coming from the vocabulary, right? And the reference will be a strict intersection or strict subset of the vocabulary, right? And again, as I said, that semantic meanings, for example, synonyms are never considered. So, but still these are very fast to compute and people still use it for initial evaluation, but you should ideally do not rely on the performance of your model on these scores to see how good your model is and whether to deploy it or not. People also have developed to counter these problems with recall and precision is that they call BLUE score, which is a very famous score for translation, which is bilingual evaluation understudy. So essentially what it does is that because you ignored the order of the words, that means you treated the words as a bag of word. So you would want that, let me not only match the word level sentence matching, but I should also do the order of the words also to some extent. For example, you would match unigrams, bigrams, trigrams, and 4 words in a row, right? Whatever the name of that is. Okay, and at the same time, so this part captures that. It says that what is the precision, ith precision, that means n-gram precision, ith n-gram precision for I is equal to 1 to 4. So you will do unigram, bigram, trigram, and 4 words at a time, and you multiply with it something called brevity penalty, which is essentially saying that the output length should be more than the reference length, because when the output length is higher than the reference length, this value will be greater than 1, and as you are taking min of 1 comma something greater than 1, the value will come out to be 1, right? But the BLUE score will go down if you generate, let's say, 10 words, but you are supposed to generate, let's say, 100 words, right? So in this case, this particular ratio will win, and this will lower the score of the this product of n-gram precision, right? Okay. Next, again the problem here is again that it is done at the word level, right? So what are the problem with BLUE score? The BLUE score, the first problem is that even human translators score very low on BLUE, right? Plus all words / n-grams are treated equally. For example, here we are simply taking the product of all n-grams, but probably having 4 words in a row matched with their reference text is a better idea than matching, let's say, unigram or bigram, right? So yeah, so let's take an example of how to do it. Let's say you have 2 systems A and B with you, and you have a reference sentence that you are supposed to predict, right? So let's focus on the system A only, and we will ignore the system B for now. So we will calculate these values, that is precision 1, precision 2, precision 3 and 4, and then this brevity penalty. So let's first focus on the precision 1. That means how many unigrams are exactly matching, right? So here we see that Israeli is matching, then officials is matching here, then airport is matching, right? So that essentially says that 3 out of 6 are getting matched. That means that you have a precision of 3 by 6. Similarly, you do calculate the precision of bigram, that comes out to be 1 by 5, because only Israeli officials is getting matched here, right? And you continue doing this, and for let's say precision of 4 is coming out to be 0 by 3, because there are no 4 words that are getting matched with each other, right? So now we calculate the brevity penalty. The brevity penalty was simply output length by reference length, minimum of 1 by 1 comma that, right? So a number of words in the output are 1, 2, 3, 4, 5, 6, and number of number of words in the reference sentence were 1, 2, 3, 4, 5, 6, 7, right? So you get a penalty of 6%. But in this case, as you notice, because one of at least one, like here two of them are 0. So when you multiply them together with each other, you get a like blue score of 0, right? Similarly, for system B, you get a blue score of 52% because, like for example, let's see the precision of 4 gram. That means here the Israeli officials are responsible is getting exactly matched with the Israeli officials are responsible. Right? So you get like 1 by 3 here, apologies. So you get 1 by 3 here, 2 by 4, and you multiply and you get a like blue score of 52%. Right? A counterpart of blue is something called Roche score, which is how much of the reference text occurs in output. So this is based on something called recall, as we saw earlier here. What is recall? Recall essentially matches that what is the ratio of number of like the intersection divided by the reference length, right? So this essentially says that for a raw score, it will essentially say that how many words were retained from the original text that was to be translated. So hence it is used for summarization. Now the obvious question here is that all of this is good and well, but as we saw that blue score may not be a good translation metric. A good translation metric, for example, in the case of let's say right, you want to judge a creatively translated sentence or something that can be translated in multiple ways or ambiguous to start with, right? So question is, can we train a model to mimic the human judgments? So the very first attempt, or at least one of the first attempts, was Blue RT. Here what they do is that they pick a pre-trained BERT and train it on a task of predicting the human score. So they collect a data set of human scores, or rather not human score, but rather blue score, and they learn to predict the blue score of a particular sentence. What is that sentence? So essentially they take the correct sentence Z, let's say it is called Z, and then they perturb the sentence a little bit and ask the model to predict the blue score, rouge score, etc., right? And they pre-train on top of it. This pre-train already pre-trained BERT model, right? Right. So sorry, they fine-tune a pre-trained BERT model. Okay. Now the second fine-tuning step is to be done on a small supervised data set of sentence and human judgment score. So essentially, you move from a pre-trained BERT, which is very general, to learning to predict a blue score, to learning to predict a human judgment, right? This is all fun and all because you have a reference sentence to like target sentence to compare it with, or compute the blue score of, or compute the human judgment with, right? But what happens when you do not have a translation task? What happens when you are trying to judge an open-ended text generation task? For example, in the case of ChatGPT, if you ask the ChatGPT that can you write a story about a unicorn flying on top of an aeroplane or something like that, then there is no good reference generation for this, and there is not a good data set for it, like that is exhaustively checking all the possible generations, right? One way to do it is called Amazon Mechanical Turk, where you ask a human annotator to judge the quality of the LLM generation. But the problem with this is that the task that is given to humans, they are getting paid against it, so they would like to finish the task as soon as possible. So the annotation is not that good. For example, there was a paper published in a well-reputed conference that on average the same task took 10 seconds on Amazon Turk, what took 70 seconds by an expert English teacher to evaluate the output of a large language model, right? So as a solution, what they suggested is that given a very large paragraph of text generated or a summary generated, you break it into like, let's say you have a long paragraph, you break it into like atomic sentences and ask the human annotators to evaluate each of them individually, and then you sum them or average them in some way. So as you can see, the problem with this is that this is too expensive because you are you're not asking a single question to humans, you are breaking it into, let's say, k number of sentences. So what they suggested is that you can sample, like randomly pick some of the sentences, and rather than exhaustively asking them to evaluate all the sentences, right? Okay. Now the question in today's era would be, can we use large language models to evaluate themselves, right? So there are multiple ways you can do it. For example, one way would be to, let's say, ask, let me go through the, let's say you this is a paper called GPT eval, published in 2023. And in this case, what they are doing is they are doing three things. One is the prompt kind of a task introduction kind of a thing, where you explain what is the task. Then you also explain what is the evaluation criteria along with the definition of each of these. For example, you can say that what is a coherence, and you have to score it between 1 to 5, and you give a definition of coherence, right? And then you tell it what are the evaluation steps, right? So essentially you are telling it to think in a in a step by step manner, which is called chain of thoughts or something. And then once you have this, you concatenate it with the some demonstration also. For example, you have input context and input target, and then you ask it what, simply ask the text, that is coherence colon. Then you feed all of this into GPT, and GPT will provide you a score that you have, right? This has been tried, and to some extent it works fine, and there it's still an open challenge and open research problem. Then you have alpaca eval, where what you do is just like chatbot arena that we saw earlier for human evaluation. In this case, what you do is you give a prefix, that means generate me a story of unicorn flying over a pink aeroplane, and then you provide the output of one of the model and the second model, and then you ask which candidate is better, and it pass it to GPT-4, where earlier it was a human being, and it will give you a score of whether it prefers one or two, right? So the problem with this is that because we are using a GPT-4 model, if you have a GPT style of generation in either 1 or 2, it will prefer that. It has been noted that it favors its own generation over the others, right? So this itself is a big challenge. What you can do is you can let's say along with GPT-4 you can also use llama, and then take a average over these, right? But the problem with that again is that llama will favor llama, GPT will favor GPT, and so on, so forth. Maybe what you can do is that never give GPT's output to be evaluated by GPT, and never give llama's output to be evaluated by llama. Okay, right. So how do you go about fact checking? Because LLMs have a huge problem with hallucination. Hallucination happens because what is hallucination? First of all, hallucination is an issue that when the LLM does not know a particular fact, it will replace it with a fake fact, right? For example, if you ask it to, let's say, write a autobiography of Barack Obama, right? It will probably create a very good autobiography because it might have seen it somewhere, and it knows in its encoding and training regime that Barack Obama is an important person. But let's say you ask it to generate the autobiography of some not so well-known person, then what if it does not know where the person was born? But it does know that usually in case of autobiographies, you have to add a sentence that says that this person was born in this particular place, in this particular country. So because it does not have that fact, it will replace that fact with the most probable state or most probable city or whatever, right? So that is called hallucination. How do you go about fact checking? So what you can do is that you give a query, it will give you a response paragraph, right? And you break that response paragraph into a sequence of facts, give it to LLM, and ask it, you have a query, you have a response paragraph, then you use an LLM, and this response paragraph is added with a prompt that break this paragraph into facts. The LLM will give you a sequence of facts, a set of facts in a bullet points. Now for each fact, you Google it or ask Wikipedia to add a Wikipedia link, and then you add a prompt that is this a valid claim. Then LLM can say yes or no based on the evidence which is grounded in reality, right? So let's say I say that I have a query that generate me a like autobiography of Barack Obama. It will give me a good paragraph on this. Then I will ask that break this particular paragraph into facts. The LLM will generate me a sequence of facts. Now, for each of these facts, I will Google it. Just copy paste the sentence in Google, get the first link in the Wikipedia. Let's say now for each of this fact comma evidence pair, I will add a prompt that is this a valid claim to LLM, and LLM will say yes or no, and people have seen that this usually works very well, right? Uh, so yeah, so that's all for yesterday. What I studied yesterday, it was based on how to evaluate LLMs and all.